today we're going to learn about green theorem. Green theorem is a line integral with a simple closed curve C which is oriented piecewise and simple closed curve. Okay, and a double integral over the plane in region R bounded by curve C. So okay guys, now we're having a curve. This is curve C, and the region inside the curve is R. So okay, C must be piecewise, which is clockwise. Okay, so the formula for this green theorem is very simple, which is integration of C, which is p dx plus q dy, which is equals to double integration of region R, which is differentiation of q respect to x minus differentiation of p respect to y. Okay, dx and dy. So this is the theorem for green theorem. It's very simple. So now we go to the example 1. Example 1 is, let's see, is a circle with a radius of 2, centered 3 minus 2, centered with x-axis is 3 and y-axis is -2. So the formula for is will be given. The curve is this. So if I write, should have, okay guys, please bear with my drawings. Okay, region 3, -2, center. Okay, so this is region R. Okay, so our Q is, okay, since R is a circle with the radius, with the radius 2, so it become 2 pi R is equals to 2 times pi times with 2, it's become 4 pi. Okay, now we go to second question, which is this one. Then okay, with a vertical of 0, 0 1 0 0 1 1 0 and 1 2, so the region will become triangle. So since D is x is 0 more less than 0 and more than 1, and y is less than 0 more than y is more than 0 less than 2x, and p is equals to xy, q is x squared y cube, and we differentiate p, we get x, we differentiate q, we get 2xy cube. So now we apply the green theorem, which is respect to x c dx plus x cube y3 is equals to double integration of region D 2xy cube minus x. So dA is equals to integration of 1, we just include this 0, 2x 0, so 2xy cube minus x dA. So dA, we can change the dA into dx dy. So now you can integrate to respect to y. X dy dx, so 1 0 2x 1 over xy squared minus xy 2x 0 dx. So get 1 0 8x 5 minus 2x squared dx. We integration respect to x. So we integrate this, we will get 4 over 3x 6 minus 2 over 3x cubed. So so we include the value 1 0, so we get back is 2 over 3. So okay, now question 3. Question 3 this is the curve, the equation of the curve. So our q is 3 xy, we differentiate respect to y, x is 3y, p 2 y squared, respect to, we differentiate this respect to y, which is 2y. So now we minus both differentiation respect to x, p respect to y is equals to 3y minus 2y, we will get y. So we use this now we use green theorem, which is cy squared dx plus 3yx dy is equals to double integration of region D, which is this one y dA. So now y is dy dx. and we just include this value here, 1, -1, 0, square root of 1 minus x squared, which is equals to, we integrate this respect to y, we get y over y squared over y over 2, 1 minus 2, 0, 1, -1 dx. Okay, then we will get 1 minus x squared over 2 dx. We integrate this, we will get x over 2 minus x cubed over 6. Then we insert the value 1, -1. Then we will get -2 over 3. So this is all green theorem. It's very simple. That's all. Thank you.
Assalamualaikum and good morning. I am Muhammad Haril Kemal to present you Cauchy's integral formula. Yes, Cauchy's integral formula. Okay, the Cauchy's integral formula, if gamma is simple, close contour n function is analytic on the gamma or n inside the gamma. Okay, Cauchy's integral formula. The formula is function of z divided by z minus z naught, that is n plus 1 equal to 2 pi I n factor f n z naught, and n must be 0, 1, 2 and so on. Okay, we go to the first example. The question is E I Z Z plus I Z and Z equal to 3. Okay. First of all, you must draw the contour. Z, y is negative I. It doesn't matter how do you draw the curve. Okay, it is anti-clockwise. Okay, the answer is 2 pi I and exponent I negative I. Okay, the final answer is 2 pi I exponent. Okay, we go to the second question. Sin 2 pi z divided by 3z minus 1 dz. Okay, the answer is trying to convert 1 over 3 sine 2 pi z divided by z minus 1/3. Okay, z is equal to 3. Okay, the counter is like this, 1/3, right? X 1/3 y anticlockwise. Okay, after that 2 pi i 2 pi I over 3 sine 2 pi over 3, and final answer is 2 pi I over 3 sub 3.
Assalamualaikum and a very good morning. Just now, Hairul had explained to you about Cauchy's integral formula, and now I will explain to all of you about path independence. Okay. Suppose function of z is analytic function in a simply connected region. If R1 and R2 is two different curve sharing the same initial and terminal points, so that the equation is R1 function z dz is equal to R2 function z dz. Okay, this is the equation for path independence. And we go to the example. Okay, the first question is we want to evaluate R 1 over z dz with R. Okay, I will draw the curve. This is X, this is Y. I intersect at point 10. This is the R. This is I and this is negative I. What I said that just now, R1 and R2 sharing the same initial and terminal point. Initial and terminal point. Okay. The integrand of 1 over z is analytic in the entire complex plane except the origin, so that this path independence, by using this we can replace the complicated looking curve R by a much simpler curve R bar. I will draw the R bar to you. Okay, this is the R bar. Looking much simpler, like. Okay, a suitable parameterization of R bar is suitable parameterization of R bar is R bar equal to ZT exponent IT, which is negative pi and pi over 2 represent the T. From the much simpler looking curve R bar, we can get the T is less than and equal to pi over 2 and negative pi over 2. From that, we can get the solution for the path independence. 1 over z dz will equal to R bar 1 over z dz. Using the integral formula, substitute the just now we can get pi over 2 and negative pi over 2, integrate to 1 over zt z bar t dt. Okay, then pi over 2 negative pi over 2 1 over, substitute exponent I t to the z and z bar t. Exponent I t I exponent I t dt. Integrate this into this equal to pi over 2 negative pi over 2 I dt. We can set out this and this. Then we solve this into integrate formula. IT pi over 2 negative pi over 2 equal to I pi over 2 minus negative pi over 2. The final answer is I pi.